This is problem 4 on exam 1 of module 8 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 4, two circular current loops are at right angles to each other as shown in the figures. There's one view, there's another view. This is the equator. That's a line of longitude, goes around the middle. Each have a radius of 10 centimeters and a current of 500 milliamps. They share a common center. What is the magnitude of the magnetic field at the center of the loops? So we need the magnetic field at the center, the shared center of the two current loops. This is going to require a lot more thinking than calculating. The key is to be able to visualize the magnetic field vector produced by each loop. We have seen that a wire loop produces a magnetic field perpendicular to its plane at its center. So if we focus on this loop here, this horizontal loop, it's going to produce a magnetic field at its center, either straight up or straight down, depending on the direction of the current. It doesn't give us the direction of the current. Let's just call it up. So this is the magnetic field from the horizontal loop at its center. The magnetic field produced by the vertical loop, the current going this way, is either to the left or the right, depending on the direction of the current. Let's call it to the right. This is B from the vertical circle. At its center, perpendicular to the plane of the loop. The magnitudes of these two vectors are equal because they have the same diameter and the same current. These two magnetic fields are always at right angles, irrespective of the direction of the currents. So if I draw B vert to the left, they're still at right angles. If I draw B horizontal down, they're still at right angles. So no matter which direction the currents are, these two vectors are always at right angles. They have the same magnitude. Let's determine the magnitude. We know the magnetic field from an arc, U naught I over 4 pi r times the arc angle of the arc. These are complete circles, so we plug in 2 pi. Current is half an amp and 0.1 meters for the radius. We plug it all in, we get 3.14 microtesla. This vector is 3.14 microtesla long, as is this vector. Each 3.14 microtesla long. We have to add them up like vectors. They're already at right angles, so B horizontal is pure y, B vertical is pure x, and we can use a Pythagorean to calculate that the magnitude is 4.44 microtesla. We don't know the direction because we don't know the direction of the currents. If we assume these two magnetic field vectors are the case, then we can put down the sum of the two vectors. This vector is 4.44 microtesla long. That's the answer to problem 4, which concludes exam 1 on